So, humanoid robots, huh? It feels like everyone and their cousin is talking about them, especially after Elon Musk and those bold claims he made about Tesla's Optimus robot.
Yeah, genuinely useful, he said.
Right. A robot revolution right around the corner. But as always, we wanted to, dig a little deeper.
Yeah, for sure.
We found some really interesting articles that break down what it would actually take to make humanoid robots an everyday reality.
Yeah.
So, are we really on the edge of some new era, or is this just a bunch of hype?
Well, the thing is, there are already a bunch of different humanoid robots out there, like right now.
Oh, really?
Oh, yeah.
Like what?
Well, you've got Boston Dynamics Atlas, for one.
Yeah.
I mean, it's famous for practically doing parkour. Then there's Figure 01. That one is being designed to completely change how factories work. And get this, there's even Phoenix, a robot specifically designed for social care.
Wow. Social care. So we're talking like robots lending a hand in hospitals, on factory floors, maybe even bringing us our groceries. I can see why people get so excited about the possibilities.
Yeah.
I mean, it's pretty mind-blowing stuff.
It is amazing. It's definitely impressive engineering. However, it's important to remember that building robots that can move and interact with the world in the same way we do, it's really complex. I mean, we have had, a few million years to evolve these capabilities. And to be able to replicate that in a machine, that's a massive, massive challenge. Like take the Riken Robear, for instance. It was designed to help lift and move patients, which is, obviously an incredibly important task, especially with an aging population.
Mm-hmm.
But instead of looking like a human caregiver, it kind of looks more like, a bear.
A bear. Huh.
Yeah, and that wasn't just some aesthetic choice either. It turns out that building a robot with human-like hands that are both strong enough to lift a patient, but also gentle enough to avoid hurting them, it's incredibly difficult.
Yeah, I guess it really highlights how much we take our own dexterity for granted and how much work goes into replicating even seemingly simple actions for a machine. And it's not just about strength and dexterity, right?
Right.
Our articles, they highlight all these other technical hurdles when it comes to humanoid robots. How do you give a robot the same kind of flexible movement?
Yeah.
Or even tactile sensing that we have? It's we don't even think twice about that stuff.
It's true. We really do navigate our world so seamlessly.
You do.
And that's the result of, literally millions of years of evolution.
Yeah.
Our brains, they're constantly processing this stream of sensory information,
Right.
allowing us to react and adapt in real time.
Exactly, yeah.
And so to try to recreate that processing power and that sensory feedback in a machine, I mean, that's a whole other level of complexity.
Totally, yeah.
Think about something like tactile sensing, for example.
Okay.
When we pick up an egg,
Right.
We're not just gripping it.
Right.
We're also feeling the pressure, the texture.
Yeah.
The fragility of the shell.
Totally.
And that's how we know how much force to use without crushing it.
Right.
And so, giving a robot that same level of sensitivity, that ability to adjust its grip based on what it's actually touching,
Right.
that is a massive engineering challenge.
It really makes you appreciate how incredible our own bodies are.
Absolutely.
And it kind of makes you wonder, with all these hurdles, why are we so focused on making robots look like us in the first place?
Right.
Is it purely an engineering challenge?
Yeah.
Or is there something more to it?
I mean, that's a question that has fascinated researchers and philosophers for a long time.
I bet.
Our sources, they offer a few compelling ideas.
Okay.
So for one thing, it's important to remember that our world is designed for human bodies.
That's true, yeah.
Our buildings, our tools, our entire infrastructure, really. It's all built around the way we move and interact with the world.
It is, yeah.
So if you want a robot to navigate that world effectively,
Right.
it kind of makes sense to design it with, a similar form.
Right,
Yeah.
right. So it's we've built this whole human-centric world,
Yeah.
and now we're trying to create robots to fit into it.
Right.
Maybe instead of focusing on making robots more human-like,
Right.
we should be thinking up how to make our world more robot-friendly.
Oh, interesting.
Right.
Yeah.
Design environments and tools that work for everyone no matter what they look like.
Now, there's a really interesting thought. It's a conversation that's definitely gaining traction, in design and robotic circles.
Yeah.
This whole idea of designing for accessibility right from the start,
Yeah.
rather than trying to retrofit robots into an existing system.
It's about working smarter, not harder.
Exactly.
Instead of building a robot that can climb stairs,
Yeah,
why not design buildings with ramps and elevators that everyone can use?
exactly. But, it's not just about, practicality.
Right.
There's also this element of, I don't know, ambition to it, you know?
Totally, yeah.
This pursuit of creating something as complex and sophisticated as a human-like robot, it's like a moonshot goal.
Oh, totally.
It really pushes the boundaries of what we think is possible.
Yeah.
And it can drive innovation in these like really unexpected ways.
Like the ultimate engineering puzzle. Plus, let's be real, we can't underestimate like the power of science fiction.
Oh, yeah.
I mean, we've been dreaming about artificial beings for centuries.
Totally.
So it's only natural that we'd want to try and bring these, fictional characters to life.
Absolutely. Our cultural fascination with artificial life plays a huge role in shaping our technological aspirations. It's definitely what inspires us to like push those boundaries. But as with any powerful technology, it's super important to consider the implications.
Oh, for sure.
If we're only focused on recreating ourselves in robotic form,
Right.
are we like limiting our thinking a little bit?
Yeah.
Could we achieve even greater accessibility and integration by exploring, alternative forms, different functions?
Right, right.
Like these are all questions that are worth pondering, especially as we continue to develop these technologies.
Okay, so we've talked about the engineering hurdles, the uncanny valley, all that, and even like the deeper philosophical questions about why we're so drawn to these human-like machines.
Right.
But can we circle back to Elon Musk and that Tesla Optimus demo? What did we actually see there?
Well, I mean, we saw Optimus walking around, like navigating a controlled environment, even picking up objects.
Right, right.
All very impressive, but...
There's always a but, isn't there?
Well, yeah, I mean, if you pay close attention to how Tesla is talking about it, they call Optimus, genuinely useful.
Yeah.
But they emphasize its potential for Tesla internal use.
Okay, so not exactly like taking our orders at the drive-thru just yet.
Not quite. And then there's the price tag, too.
Right.
Early estimates put somewhere between